Cool. Good evening, everyone, and welcome to the December virtual meetup by the official CNCG Kochi group. Today we have Aditya who's joining us to talk about testing in Kubernetes. How can we use cloud native technologies like test containers and TestKube for running integration testing at scale, cloud native way? To quickly introduce Aditya, he is working as a senior SRE at Sentinel One, and he has been playing around with Kubernetes and serverless for quite some time. With overall 8+ years of experience, he has been a speaker at multiple events, and he's supporting the local CNCG chapters. And without further ado, I would like to pass on to Aditya. Aditya, let's get started.
Thanks a lot, Adarsh, and everyone at CNCG Kochi for having me here. Very glad to be here and present my first virtual meetup at CNCG Kochi. So my topic for today is about it's mostly about running integration test with test containers and running them at scale using TestCube. So a little bit about myself. So my name is Aditya Krishna Kumar. I have a total of 8 years of experience in DevOps and site reliability engineering. I started off my role as a site reliability engineer, but more or less, I mean, the title was a SRE, but it was more or like a support role. So from there, I was able to, work with like AWS cloud and understand the principles and fundamentals of site reliability engineering. Then then I was then after some time I was working with a small to medium business which was focused on which was on a DevOps role. Although the role was for DevOps, but I was also doing like quality assurance as well as a little bit of solution architecture as well. So it was like kind of a jack of all trades, master of none kind of role, where I was working with uh, technologies like Node.js, Python, shell scripting, and so on and so forth. So then later in my career years, I was also I also worked with Kubernetes and worked with like multiple clouds like AWS, GCP, Azure, and everything. And recently, I've started to have home labs. Started to set up my own home lab, which is on Kubernetes and Raspberry Pi. So yeah, that's a bit about like my journey with cloud, uh, overall like software development lifecycle and all the things. So reason why I'm talking about all the things is about the software development lifecycle things is because we have like whenever talk about like developing software, we are just building it, testing it up to some extent by doing some manual testing and such. And after we find that our smoke test or manual test are success, then we go ahead and deploy it to staging and then eventually to production environment. Now, let me introduce a small concept about like integration testing, where why do we need it and what is it about. So integration testing itself is about like where we test how multiple components work together in a system. So usually you would have unit test, which is like you would write mock about your like whether your particular module or your particular function is working as expected. Then you would have integration test where you test about all the where you test with other remaining components. For example, if your application or your module requires uh, any sort of like, let's say, database, say Redis or even like Postgres database, so you want to have a test against all those components and see that how your application is behaving, then you would have integration test for that. End-to-end test is all about like you test the entire system from a user's perspective, where I earlier mentioned about smoke testing and things that would come under end-to-end testing. Now, integration tests usually connect real components. Your code talks to a real database or any sort of message queue, or even like any sort of like fake API or something like that. So you can have an integration test just for that. Now, why integration testing matters? Because unit testing can help you pass your SQL. It can pass, right? Like if your SQL query has a syntax error, mocks really don't catch any sort of connection timeouts or any sort of serialization issue that you would see with uh, working with real databases or real systems, subsystems. So integration tests help you to catch all of these before any of this hits a production environment, and it helps you to reduce this surprises that you would always have, that whenever it comes to development, that is, it works on my machine. So you would avoid any sort of those surprises whenever you are having integration test in your software. Now, again, with integration testing, where I talk about integration, when I talk about integration testing, you would have all the I mentioned. So there are some other problems also when it comes to like traditional testing. So whenever you are writing your test suite, you would generally write a mock function which would run with like whatever mock you would like fake up some data, or you fake a database connection, or such things. You usually just have a mocks. They don't really catch your integration issues. They just return what exactly you are expecting, but it does not like test any sort of like edge case behavior or any sort of edge cases testing. When it comes to shared databases, so for example, if you are running, let's say your database is your software is having multiple databases, for example, and uh, each of your component is working on their own like Postgres database schema, and for each and every test you might have like a Postgres database running for it. And when you want to like have your one module connect to uh, let's say your module A is working with one database, and your module B is also wants a database for its own testing and its own schema, but you don't really spin up another database instance, because the database port that it's trying to use, it's already occupied, and you can't like reuse that same database for this thing. And that way your test that you are trying to write, that might be flaky in nature. It One test just pollutes the data for another, and when you try to run all of the tests together, it might fail. Then and any sort of like works on the machine problem that I talked about. So environment might have their own inconsistencies that might be there. Your let's say you're running your local Postgres version which is on 15, your staging database is on version 12, and your production is running on version 11, which is that way you might have this kind of database version inconsistencies. And that I'm talking about just one database. There might be multiple, your system might use multiple databases like Redis or something else, and that might have their own version metrics that you might need to solve. And managing external dependencies is also painful, like installing all the databases on your system, managing the versions, and doing cleanups between each and every test run. So that kind of becomes painful. So, I mean, you do have Docker Compose as a solution. Docker Compose does help you to solve these problems with the versions and all the dependencies things. But when it comes to like running, let's say you are running one Docker, you have left your Docker Compose stack run up and running in one terminal, and you try to switch to another terminal to run your other subsystem test. And when you try to spin up the Docker Compose for that second subsystem, that fails, and it's not able to come up because you have port mismatch, or and if you try to map another port, that causes inconsistencies with other developers environment. So uh, those are like some of the problems that you generally have when working with even Docker Compose or with traditional testing. So there is a technology called test containers. How does it help you to solve this particular problem? So what is test container? So it is a library which helps you provide lightweight throwaway instances of databases, message brokers, and any other services that you might need as Docker containers. And so let's take this code base as an example that I have. So this is a Python example that I have. So it's trying to use a Redis container. It's trying to use a Redis container instance with a particular Redis version, and then it tries to once I have this container up and running, I try to get a client connection from it, and after I set a client, I just try to do a simple like get set clause. I mean get set method where I just try to get and set some values and do my test. One of the key benefits that I have with test containers is it creates real services. It does not, you are not working with mocks anymore. You have a real Redis database or a real Postgres database or whatever. So you can have a real services for that. And each and every test run, you will have an isolated container for each and every test, and it is also reproducible anywhere, wherever you run, whether it is for Windows instance, whether you are running on a Windows machine or a Mac machine or a Linux machine, it will always be reproducible. Also, test containers is like language independent. It's available for Java, Python, Golang, Node.js, and much, and many more services, many more languages. So you can use that. You can use test containers with any of your programming language of choice. Let's talk a bit about the test containers architecture. So here in this case, I'm having this as an example for my demo, which is a Python based application for which I'm running this PyTest. I'm using PyTest as my library for running the test. So what it does is so when I run my PyTest command, it creates a test container. It uses the test container library. It connects with a Docker daemon, and the Docker daemon then connects to connects to my Docker host. In this case, my virtual machine. My local machine. It creates the containers for Redis and Postgres. Like this is an example. It could be any other containers. Yeah, so that's about the test containers architecture itself. Now let me talk about my application. This thing. Okay, yeah, the UI might not. I mean, the code base might not be that much. So let me just show you the architecture diagram itself. So yeah, this is a bit about the architecture diagram itself. Right. So as I was mentioning, so this is the architecture diagram where I mentioned about that I have a particular so this is a Python Flask application which just tries to run as a DNS querier, where it tries to query some of the DNS servers. In this case, it is Google or Cloudflare. It tries to query the DNS servers, and it resolves the response, and then after that it gives me whatever the DNS query response, it gives me back as a response back to the client. So that's a simple example of this. Now in this case, both the HTTP client as well as I've also written a CLI client. What it tries to do, it tries to send a DNS query, but it's in a base 64 format, just because for encoding purposes. And once I have the DNS query available as request, it then decodes I have one utility which decodes the DNS record, and then it sends it to my resolver, where it tries to connect to my DNS servers using UDP and gives back the response. Now I've also included, just for the sake of I've implemented a simple naive implementation of a rate limiter, where if someone is trying to query too much, send too much of DNS queries within a 1 minute time frame, then it will then whatever the query is, the additional request, those will be blocked, and only and for any sort of for like storing the IP address and this thing, I've implemented Redis as a database mechanism to have this increment and like expiry logic, which is like a sliding window based rate limiter for this. And there's a simple health check for like for the Flask API for the health. So yeah, that is the all about like the architecture of this application, this demo. Let's jump back a bit to the slides. Yeah, so as I was saying, so it resolves via Google DNS, Google or Cloudflare DNS. It then rate limits using Redis, and yeah, and then it's all about the rate limiting thing. So yeah, so let me just show a bit about the application itself. Let me show it by how I run it. So yeah, here's the application itself, the main Python Flask that I was mentioning about. And here is the main thing about like how to parse, decode and parsing the query. And then I have some like slight e-tag validation for verifying if there is you know, if someone just tries to request the same query over and over again, then it gives this does its a bit of like client side caching as well. Yeah, so let me just show you a run about this. Yeah, here it is. Okay, let's do a Python run.py. Yep, so here's my this request, and let me open up this one. And I'm using Poetry as the dependency manager for this. By the way, all of the source code that I have, all of it is also available on GitHub. I'll share the link soon enough, such that like you can also like, try out this application. Okay, here is this thing. Yeah, and I run Python CLI. Yeah, it gives me some help. Right, so let's say I want to get the response of let's say github.com, and I want to have the query as a records. Then it gives me the response that what was the response. So it gives me all the e tag, which is for the entity tag for the client side request. It gives me all the things about like what are the records, like what was what are the answers it gave me. So it gave me the IP address. And it also gave me that what was the question I asked and which DNS resolver resolved this DNS query. So this is the working. This is the application in short about doing the like just demonstrating about doing some DNS queries. So yeah, that's a short demo of the application itself. Now let's jump a bit to the test containers itself. So let me show you how I wrote the test. So all of this I'm using a PyTest framework for all of my test features. So here in this case, if you can see here, so if you see, I'm setting up a Flask. So each and every module scope for the entire scope of the module, I'm using this single Redis instance where I create this and it tests the DNS resolution. So for this particular set of test fixtures, it will use the same container, same Redis container for all my DNS resolution related for this particular test suite. So in this case, what I'm doing, I'm using this. This is a test containers library, and here I'm using Redis as a submodule, which I mean a Python module which is available. So I use that. I specify that what is my Redis container, what's the image that I want to use. I also set up the environment variables because this is what my application uses as the environment variables for this. So it gets the container IP and it gets the expose port for 6379. So I'll show that how this would look like in the when I run the PyTest test suite, then I can show that how the port would look like. Then I also have after this Redis is created, then I create a test client out of this. After this, for this particular test case, I'm sending a sample DNS resolution for like a sample DNS hex query. So if you might not know, so whenever you are sending a DNS query, it would always have the set of headers and set of flags that you want to use, that you want to set up, and the particular record that you want to set. So you would send this as a you would set this as a hex record, and then you would try to send this particular query to your DNS resolver. That will then resolve this query and then gives you the final response with all the details. Now it gives me then I assert that if there is an answer, like if I get any sort of result, and if the length of response is 0, and I see that if a result data is already there or not. So these are some assertions that I have for this. Similarly, this is another test that I have for rate limiting, where I specify that same DNS that I'm trying to send, and then yeah, I set it as base64 query, and then some port I've defined some port mapping. Then I try to set up this then I have some wait. Then I just run my application itself with particular port and everything. Wait for it to get ready, and then after then I try. Then this is my main logic for testing the rate limiter, where in this particular suite, like earlier, I'm setting the Redis container. I'm waiting for my server also to get started, and once both of these are working and I have this, then I set it with my localhost. I mean, I set the URL for my application. Then for a range of 105, so essentially I'm sending 105 requests in 1 second. Then I just send this request and see that how it behaves. If my response code is more than if it gives me 429, which is the standard code for rate limit exceeded, it adds the failure records, and then it adds and if it is 200, it adds the success. So I have two buckets. Then it sees that that if the success count is 100, and then if it is failing for and if the number of failures are more than one, if both of these are success, then only it will mark this test as succeed, and then it will after once this entire test runs, then it kills my server process that I have. So I think, yeah, that is, and I also have this another test to have some validation test whether the DNS query is valid or not. And this is another for testing if I have an invalid DNS query. So yeah, that is a bit summary about what are the test cases that I've written and how I might have created this. So yeah, let's jump to the testing itself. So yeah, this was the CLI application. Where's my this? Yeah, here's my DNS response that I have. I just killed my Python Flash server. Now I just run pytest -r and with p. So this is just to have some more verbose output just for the sake of demo, such that I can show you that how the test would look like. So it's, as you can see, it creates some few containers here. This is a cleanup container which TestContainers itself creates to essentially clean up any older containers or older any sort of leftover containers that I might have after the test. So it does all the test. I mean, the test got completed fairly quickly. And let me just clean up the images a bit such that I can show you that how it looks like. Yeah, this. I don't want these. I'm not using Docker desktop here. I'm using Rancher desktop because I mean it's like an open source alternative to Docker desktop. So let me just run the test a bit once again, just to show you in a bit that what's going on. So it creates a container for the cleanup container. This is named after, if anyone watches anime, this is named after that the death god that you have in that anime called Death Note. Ryuk, so who is like responsible for doing all the cleanup of your containers. So as you can see, let me show the logs as well. Yeah, so it says that it adds a container. It has a new client which is connected. It's the Redis container. Okay, wait. Yeah. So okay. So and if I show you about this thing, if you see here, right here, this is having a different mapping. Okay, the container went away, but you can see that it was having a port mapping of sorry, what was the port mapping? Yeah, 6379. For the port 6379, it had another mapping. Just give me a minute. Yeah, okay. So it had a port mapping of 6379, but for outside port, it had a different random port mapping. And that port mapping was made available to my test suite such that I don't have to specify the port each and every time I run my test suite. So that way it always ensures that I always have a clean set of Redis image every time I run the test. So yeah, that's about the test container itself. And let me show the logs that what it what how the test would look like. So it created some containers. It created a Redis container for me. It captured it tested the DNS query, whether the DNS query was valid or not. For the wrong DNS query, I have this that if I have a invalid base coded string, base 64 encoded string, this test failed, but it also gave me that I was expecting an error, so this test passed. Now coming to the rate limiter itself, so it did all the rate limiting query, and it did for a, so I've specified the bucket. So it means that for a 60-minute interval I can accept 100 requests, and if I have more than 100 requests, then rest of the other requests will be failing. So it's a bit of a naive implementation of the rate limiter, but I just have it just for the sake of the demo. And the moment I fill the bucket, and so rest of the request which I had, that would start to face 429 error code. So yeah, this is the example of the rate limiter logic that I have. And yeah, that is about the test containers itself. Yeah, and then, so if anyone is having any questions or any questions so far, happy to take them now.
So almost all popular data stores and dependencies are available as part of test containers.
Yes, that's right. So if I show you the test container website itself, so you do have various testing modules. So test containers usually have these modules against which you can run your test upon. So you can use containers like Azure based services, or if you have if you're having dependencies on AWS, you can have AWS the local stack as well. So that way you can have, even like nowadays everyone is all about like AI and stuff, right? So you can have a Docker model runner and MCP gateway as well to test out like any of your MCP applications, and if you want to do some test them out. And it's having like a lot of you can test a lot of modules, even Kafka also. Like if you want to avoid the setup issues with the Kafka, you can have them set up locally and uh, run your test. So yeah, it has a lot of it has a good amount of support for various open source databases that you can think about. So yeah, it.
Also, some of these databases would have a distributed nature, right? For example, Redis would have a leader for or a cluster setup. Uh, are those also supported, or this is for very basic level of testing?
It also supports like even clusters also for some cases, but I think that totally depends on like how the module is documented and how you want to uh, set it up. You can definitely have a like a Redis cluster also set up with this.
Got
I just went with the simple setup just to just to keep the demo a bit lightweight for our audience. So yeah.
Cool. Thanks.
Okay, let's continue with the further part about testing. So one of the things that we have, so with this, I think yeah, we have. So whenever you want to have all the testing, it works great on your local machines. You have all the things up and running, and even with traditional CI like GitHub Actions, you can easily integrate it with. You can easily have test containers running inside your CI and run all your tests. But now, what about like Kubernetes? So if I already have a Kubernetes cluster up and running, and I want to like maybe save some cost on my testing infrastructure, and I want to maybe use whatever I'm already paying for the compute, I want to use them as part of my testing strategy. So I can do that with Kubernetes. But whenever we have like such kind of test where you require this Docker and Docker kind of setup, right? Because at the end of the day, test containers, it uses the Docker API to talk to Docker daemon and create the relevant containers. But this is not really like possible within Kubernetes, because uh, you would need a solution like Docker in Docker or something like that. So but whenever we talk about like Docker in Docker, or even like mounting the host Docker socket, you do have like challenges around security. That is, if you are using, let's say, Docker in Docker, that would require you to run a privileged container, which becomes a security concern whenever you are dealing with, let's say, shared clusters. And other option is, let's mount the host, whatever the node host is there. We mount the host Docker socket. That kind of breaks your isolation, because that way your test, like whatever your test, if I try to, let's say, want to see that if I want to do any sort of container escape or such things, I can do that if that if the Docker socket is mounted. So I can see that what are the containers are also running on that node. So that again causes security concerns. Third option is, you can use something called TestKube, which is like you can use which is like it's a purpose built tool which is out there for running test on Kubernetes with all the proper isolation and security measures that you want. So what is TestKube? So TestKube is a Kubernetes it's a Kubernetes native testing framework which is available from KubeShop. KubeShop is also, if you might not know, KubeShop is also has another popular product called BotCube. I'm not sure if anyone else have heard about it, but BotCube is essentially, it's also another popular tool which helps you to talk to Kubernetes clusters using your chat integration like Slack or Microsoft Teams. So KubeShop is also behind BotCube and also behind TestCube. So whenever you want to run your test inside, so whatever your test that you might have, it runs inside your Kubernetes cluster as Kubernetes jobs. It does have its own custom resources. It's called test workflows. It uses that to define all your testing, your test workflow and everything. It also it provides Docker in Docker as a managed sidecar. So all the security, so test container just simply works for you. I'll show that how it is, how it functions in the second part of the demo. uh, and also it also integrates well with your CI/CD tool. So if you are running GitHub Actions, GitLab CI, even Argo CD or anything like that, it integrates well with your current CI/CD tool. And it also provides a dashboard as well for viewing all the test results, logs, and all the artifacts, which I'll show a bit in a bit. So yeah. let's talk a bit about the TestCube architecture. This one is a bit incorrect. Let me show the proper one. So this is again from the TestCube docs. So if you might see here that we already have this as control. I mean, in this case, we have.
Sorry to interrupt. Can you please zoom the image a bit?
Yeah, sure. I hope it is visible or not. Maybe even more.
Yeah, it's visible now.
Yep. Thanks. Yeah, so TestCube has two components. One is a control plane and one is an agent, which is agent is responsible that runs on your Kubernetes cluster, and control plane is something that you can either run it on your self-host, that's either on your own, you can self-host it, or you can use the cloud version for the dashboard. So TestCube agents usually have a very lightweight setup. They only just have an agent API which listens for any of the job that you might want to run, and it triggers a workflow job for you, which is again like another like a CRD for running your workflow. And it also has a NATS queue just to put all your test within a queue and then pick it up and schedule the test. And TestCube, there is also something called TestCube operator, which manages both the agent API and your NATS instance. And when we talk about the control plane itself, the control plane is also having its own, like they have their they have their own REST API. They can use it, and which essentially talks to all your which also talks to your agents, and then what happens is whenever you want to store any of your test results or any of your artifacts, it has external dependencies like MongoDB and S3 for storing all your artifacts. It also has a DEX integration, which also helps you to integrate with your identity providers like OpenID, Okta, Active Directory, and such. So, yeah, and since TestCube does also have their own like enterprise version, so they do have this own licensing server and things which talks to a licensing server for all for managing all your licenses. So yeah, that is a bit about the architecture. Let's jump back to the presentation. This is a simple definition that I have for the test workflow. So this is again a CRD, which is there for defining how your test would look like, what are the services that you want to run on, and all the things. So as you can see, the name I've mentioned is a DNS parser, which is my my service. I'm mentioning the name. I'm also mentioning that what is the Git URL. In this case, I'm mentioning that this is my Git URL. This is my repository that you want to check out. And these are some additional services that I'm dependent on. In this case, I'm running a Docker the DIND container as a sidecar, and it's having privileged containers. But don't worry, this won't be there as a as a persistent container. This is only for the duration. This will only be available for the duration of the test, nothing more than that. As a part of my test steps, I have mentioned that just run the test for me. Use this particular DNS executor image that I have. That in this case, I've just customized it a bit to just have all the libraries and everything beforehand, such that it does not waste any time on like pulling all the dependencies and all the things. And it runs the pytest command with the command that I just mentioned. And I'm just exposing the Docker host. In this case, this DIND containers TCP port. I'm just exposing the TCP socket to this container, such that such that test container can spin up another container for all the dependencies that I have for my test suite. This I'm not sure if this might be visible or not, but I'll just read it. I'll just read the slides a bit on this. So TestCube does have a bit like it has just have like it's not just like about running test. It does have even a few more like powerful features. it does not only let you run sidecar containers, but also like databases, message queues, and anything else. Again, this is only I'm only mentioning this because TestKube does have this feature, but I'm not leveraging those because I already have it as a part of my test container suite. So just yeah. And it also have artifact collection facility, where you can save all your test reports, screenshots, logs, anything that your test produce. You can store it as an artifact. You can also schedule it with cron expression, where you can schedule your test to run nightly on a nightly basis. And you can also have parallelism, where you can run the test across multiple pods for faster execution. So if your test suite is having any sort of parallelism, or if you want to have run multiple tests in parallel, you can have that using TestKube. I already mentioned about the Docker and Docker thing, that how it does and how the test container connects to it. Yeah, and this is a bit about like running the test itself. I'm just mentioning that this is how you run it, and I already have a workflow definition. I just run it. I'll just show that in a bit about like how the in the demo part. Let's jump quickly to the demo bit about TestKube. Let me just go on to it. So here's my Kubernetes cluster, which I already have. I have just created a demo cluster just for this. This is hosted on DigitalOcean, and its name is like TestKube cluster demo. Yeah, so I just mentioned that. And in this case, I've already have it in my TestKube namespace. I already have the API server, the agent already deployed, with the API server and the NAT server already running. Then I also have the test. Here's my dashboard. It's already, so I'm using the cloud version of TestKube just so that I can show you other things, because again, there is a small limitation about this, that you can't use test container test with self-hosted version of TestKube. You can, although you can use something else like Playwright and things for your testing requirements. Yeah. So yeah, this is my the dashboard. It shows that what is the ratio, how many failed execution and how many total execution that have happened. Let me show the workflow file quickly. So this is the workflow file that I have for my test workflow. So as you can see, this is having some working directory that I've set. I also specify that how much CPU and memory it should consume, and what's the timeout for this particular service. And I mentioned that all the things about like what image to use for the executor, what's the command and everything. Let me quickly show you the Docker file for the TestKube as well. So it's pretty simple. It just has Docker as a dependency. It has PyTest for my test suite and test containers as my dependency. And it also has all the requirements that I have as part of my application. I already installed it beforehand, such that I don't spend a lot of time on managing the dependencies. Yeah, I think that's about the TestKube itself. Now let me trigger the workflow once again and show you how it looks like. Right. So if I talk about this one, what was the name? Test workflow. So here I already have this workflow already present in here. Oops. I hope everyone can see this, right? Or should I zoom in a bit? Let me just zoom in a bit for this thing. Yeah, I hope everyone can. Okay. Yep, I think that's about it. Okay. Yeah, so as I mentioned, this is that same workflow. I already deployed it in my cluster. Now I already have the TestKube CLI already present in my local machine with all the things. Let me just try to run this once again. So I already have the TestKube. So this is the CLI. I'm running this this test workflow that I have with the name. Then watch for it, watch for the live events that might be there, and it should be running in the TestKube namespace. So I trigger this test. Yeah, so since I already ran the test beforehand, so all the git checkout and everything that worked a bit faster. So git cloning worked. Then it starts all the services. It assigns it to a particular node. Let's check a bit on the test execution. Okay, it might not be here. Yeah, so you can see here's the test containers that are already running. So this is my DNS executor. So it already shows all the logs that I have for what it is, like what is the test container, what it is trying to pull and everything. So this is the execution itself, and this is the sidecar, which is on which test containers will be creating the containers on. So this is the sidecar that it is having. So these are the two containers that it's there. And yeah, let's wait for it. Let's wait for the test to complete. So by the time this test run, I can show you the dashboard as well, how it looks like. So if you can see, yeah. So it already it's showing me all the live log that from the containers, that what are the services it started, what is the test that it's running, and everything. Since I'm not generating any artifacts, this won't show me any artifacts before. So let me quickly, in the interest of time, I'll also show a previous execution that I did. So it ran all the tests for me. It took around a minute. It ran all the test cases that I mentioned in my PyTest command, all the test containers related things, like what DNS queries to run. I mean, all the test suite that I have, and then it stops all the services that I created as part of the test suite. So yeah, total execution it took around 3 minutes. Again, because this was the first time I was running the test, it took a bit longer. But if you do if you try to run the test even more, so it does. So because the git step was already done beforehand, the execution itself took slightly faster. So yeah, that mostly does it for the demo bit. Let's jump up quickly back to the presentation as well. Now, if you want to integrate this kind of thing in your CI/CD workflow, it is pretty simple. Like I just showed you the CLI way to run it. You can have that same thing running for your in your this as well, in your GitHub action, where you can mention that what is the uh, like what workflow to run, and what a particular namespace to run on. Let's talk a bit about the best practices as well when it comes to setting up test containers and having all your as part of your integration test workflow. So whenever you are running any sort of images, it should not use the latest tag. It should use specific tags, and always try to set up resource limits whenever you are running it on wherever you are running it, whether it's on your local or whether it's on your Kubernetes cluster. Always set the resource limits such that your test does not become responsible for bringing down the whole your testing cluster. Then always you try to use readiness probes such that whenever let's say you are waiting for your test container to be ready, you can always have this wait strategy where you can see that if once a particular log line or a particular health check is successful, then only you should start your test. Whenever your fixtures are there, you should scope it properly. For example, any sort of expensive containers that you might have, let's say like databases, they should be scoped for the entire module, like for your entire test suite. And whenever you need any sort of isolation, you can use a function scope for it. Then also you should always have a fail open whenever you are working with production code. So if your Redis code, if your Redis instance is down, you shouldn't be blocking all the requests. You should log the error and allow the request through. So yeah, this is one of the example that's already there in the rate limiter code. Once again, this is this might not be properly visible because of uh, the font condition, but I'll just read it out a bit. So whenever you are using any sort of local development, use the test containers directly. And if you want a Docker, if you are running your test in a CI, like a continuous integration environment, use GitHub Actions. Test containers also works out of the box from there. For any sort of Kubernetes native CI, or you want to, let's say you want to run any sort of test inside the cluster, you can use TestKube along with the test containers. And whenever you want to have any sort of scheduled end-to-end testing, you can use the cron workflows, which is available within TestKube for any sort of end-to-end nightly regression test that you want to do. For multi-cluster or multi-environment testing, you have like a TestKube cloud, which provides kind of this unified dashboard that I just showed earlier, and easy management of all your test suite. Yeah, so in summary, whenever you want to, if you don't want to just have mocks and just want to use real services, then you can use test containers for it. TestKube provides native Kubernetes native test orchestration. It handles all the complexity of running Docker dependent test within Kubernetes, and also various other tests like browser based test or anything like that. Both together, they can help you enable like scalable integration testing within your Kubernetes environments. You get both the developer experience of test containers along with operational benefits of running it on TestKube. Here are some of the resources that are there that I just mentioned, like documentation about both TestKube and test containers. I'll share all the slides as well as the code later as part of the this session, and then we can then if you have any like questions or concerns, feel free to reach me out on LinkedIn or elsewhere. So yeah, that mostly concludes the presentation, and I will now open the floor for any questions.
Aditya, how would you suggest using this for a perf test scenario? For example, like there is this Grafana K6,
Right.
but you also feel free to pitch in. Like, how do you do if you want to do a perf test along with all of this with K6, and how do we compare all of this?
Right. So if you want to have K6, you can use like K6 to run all your load test suite. You can have a K6 running as part of your test container suite. And whenever you want to have K6 do all the performance testing, you might have. I mean, I'm not really like familiar with the K6. I mean, I've heard about it, but obviously there might be some configuration that what particular endpoints to hit, how many number of agents, I mean, how many number of users that it should be hitting, and all this configuration. So you'd have this defined in a configuration file. So you can have test container look at that particular K6 file to sort of like start running this integration test. I mean, start running your perf test, and then basis on the response and all the reports that it generates, you can have all those artifacts also put in somewhere as part of your TestKube workflow, where all of these artifacts from your K6 results, you can put it in some central place, and then you can have your QA or your performance team have a look at those performance reports from that artifacts. And you can run it on a nightly basis with the scheduler, TestKube scheduler, cron scheduler, where you can have this on a nightly basis and have them those reports available to you.
Got it. So we could even run perf test suits without K6 with this
Yes.
setup as well, right? Like we don't really need to depend on K6.
Yes, I mean K6 you can have it as part of your test containers, where you can have a test container spin up a K6, then have the test container to essentially look at that K6 configuration, and then K6 would then run all your tests for you, and then whatever results that are there, whatever artifacts that it generates, you can orchestrate all these test containers based workflow using TestKube, and all these artifacts that it generates, you can have that available to look at. Yeah.
Sounds good. Thank you.
Is there any more questions left? Uh, there are no more questions. Can we wind up the session? Yeah. Yeah. Thanks, Aditya, for your contribution to CNCG Kochi. And thanks for everyone who have joined and support us. We will be sharing this video in our YouTube channel. So yeah, if you miss something, or like if you want to try from Aditya's session, please do check the YouTube video. We'll be publishing in 3 days. Yeah, that's all. Thanks everyone for joining. Yeah, bye. Good night.
Thanks a lot, everyone. Bye.